A gas leak and explosion, the results of insularity. It is hubris to imagine that we can infallibly prevent an thermodynamically favored event. P.G. Urban, reviewing the first edition of this book, four men were killed. Several injured, and a compressor house was destroyed when a leak of ethylene ignited. 4.1 shows some of the damage. Explosion experts estimated that between 5 and 50 kg of ethylene leaked out into the building during the 8 minutes or so that elapsed between the start of the leak and the explosion. Detailed examination of the wreckage enabled the source of the leak to be identified. It was a badly made joint on a small bore line. The recommendation made to prevent similar explosion fell into four groups. Ways of preventing leaks or making them less likely, ways of minimizing their effects, ways of reducing the probability of ignition. Underlying all these ways of removing the managerial ignorance and incorrect beliefs that led to the accident. Most of the recommendations apply to other plants handling hazardous materials, particularly flammable liquid and gases, and may apply to all process plants. Preventing leaks. As already started, the leak of ethylene occurred from a badly made joint on a small diameter line, about 12 millimeter internal diameter. The joint was a special type suitable for use at high pressure, and assembling it required more skill than is required for an ordinary flange joint. Once the joint had been made, it was impossible to see whether or not it had been made correctly. It would be easy to say that more or more care should be taken in joint making, but this temptation was restricted was resisted, and the underlying reasons why the joint had been badly made were investigated. There were two reasons. Learning from accident. At one time, the assembly of high pressure joints was carried out only by a handful of craftsmen who were specially trained and judged to have the necessary level of skill and commitment. This was resented by the other craftsmen, and a change was made, all craftsmen being trained to the necessary standard, or so it was thought, and the work carried out by However, was available manpower utilization was improved. Unfortunately, some of the newly trained men did not have the necessary skill or perhaps did not understand the importance of using their skill to the full, and the standard of joint making deteriorated following the explosion. A return was made to the original system. In addition, several other actions were taken. A standard for the quality of joints was specified. An attempt was made to explain to the craftsman why such a high quality of joint making was necessary and the result that would follow if joint making was not up to standard. Obviously, this take was made easier by the result of the explosion, which were known to all concerned, and it would have been more difficult to do the sum on a plant which had not suffered a serious leak. Nevertheless, it is something that should be attempted on many plants. A system of inspection was set up. The joints had to be inspected after the surface had been prepared and before the joint was made. Initially, all joints were inspected by but as the inspector gained confidence in the ability of individual craftsmen, they inspected only a proportion selected at random, usually in the atmosphere that excited. After the explosion, the craftsmen accepted inspection more readily than they would have done at the other times. Better tools to make joint making easier were developed and made available. These actions reduced the leak frequency by a factor of about 20. Although leaks were quite common before the explosion, about 10 per month, most were small, nobody worried about them. The attitude was they cannot ignite because we have eliminated all sources of ignition. Unfortunately, this view was incorrect. It is almost impossible to eliminate all sources of ignition, and as we shall see later, not everything but that could have been done to eliminate them had in fact been done. A study made after the explosion showed that several ignition had occurred in the past on this and similar plants, but that nevertheless the probability of ignition was very low, only about one leak in 10,000 ignition. This low probability may have been due to the fact that the high pressure was dispersed by jet mixing. On most plants, the probability of ignition of small leaks is probably between 1 in 10 and 1 in 100. For large leaks greater than several tons, the probability of ignition is much higher, greater than 1 in 10 and perhaps as high as 1 in 2. A third reason for the large number of leaks was the large number of joints and values. The plant consisted of several parallel strings, each containing three main items of equipment. Their reliability was not high, and so, in order to maintain production, a huge number of cross-versy and isolation values were installed so that any item could be used in any string. The money spent in providing all this flexibility might have been better spent in investigating the reason why online time was so poor. Later plants bolt after the explosion had fewer streams and fewer crossovers. Minimizing the effects of leaks. Although much can be done was done after the explosion to make leaks less probable, they were still still liable to occur from time to time, and several actions were taken to various extents to minimize their effects. Taken together, they constitute a defense in depth. If one line of defense fails, the next one comes into operation. They may be summarized by the words detect, warn, isolate, disperse, vent. Detect flammable gas detectors provide a cheap and effective means of giving early warning that a leak has occurred. Action can then be taken to ignite and so on. They should be installed on all plants for experience shows that leaks of hazardous materials are liable to occur such as all plants handling liquefied flammable gases. It is particularly important to install them in buildings as very small leak indoors and can cause serious damage in the open, or several tons are usually needed for an explosion, but in a building of few tens of kilograms are sufficient. Enclosure increase explosion damage in two ways. It prevents dispersion of the leak and it prevents dis- dissipation of the pressure generated by the explosion. It is also important to install gas detector in places where men are not normally present, as leaks may otherwise continue for a long time before they are detected in the present cause. We know that the leak was detected within 4 minutes of its start, as by chance someone visited the area of the leak before it started and someone else saw the leak 4 minutes later. The procedure for shutting down the plant had been started but had not progressed very far when ignition occurred after a few minutes.